Welcome. Today we're going to take a look at how we can use the new observation struct inside Swift, available with Xcode 26 Plus. So we can actually look at the changes to either @model or @observable data types inside a Swift project. And so we're working with iOS on here. I've got Xcode 26 on my machine is what we're working with. And we want to look at, we can actually see the changes of that. We're also using the async algorithms package, so we can combine those asynchronous sequences into a single stream of information we can look through and analyze that as they go through. So that's what we're going to take a quick look at. And so here we have our project right here. You can see I've got my class DataObserver. One of the requirements is that when you're working with it, the class you're working with has to conform to an @unchecked sendable, or has to conform to sendable itself. We're doing to do @unchecked sendable on this specifically because, well, it's not going to get checked on this, so that's what the @unchecked is going for on that. And we're not going to be the things that are in here, we're not have to worry about that because we do have a model actor we're talking about. We want to just have that just not be processed with it. You can see I've got my init right here where I pass it the observed item, the observed thing, and the calculator. I'll be working with that. This is just a quick demo, so you could use this to look at how you can possibly apply this to other situations. And in the init, just assigns the values just by default, so that's really pretty self-explanatory, nothing special there. However, we do have our observe method. Notice it's been marked with the async indicator because it's an asynchronous method, so you have to use await when you call it. Just a quick little blurb on that. And we're making a list stream. I like stream instead of sequence for the naming on this because it's what syncs in my head. It probably comes from my background in Java, but it's an async sequence in Swift, but stream is just a quick naming for it, and it sounds nice for writing it. And so to create that, we say that list stream is equal to observations, and that's a type within Swift, and we're using then a squig. We have to do a capture of self unless we want to do an unwrap on it, and I'll just capture self to make it really easy. So self in. And then watch component equal observed item.item. So I'm going to look at the list of items that are inside my observed item. And I return an observation sendable because what you send back out of your observation has to be sendable because you're sending it out. So of course it has to be sendable. And my observation sendable is just a quick little struct we have to hold over that. Pull it up here in just a minute. And I observe the property name and its content. And that way I'm accessing, hey, that's what the .count is that we're looking at that specifically. Let thing stream be an observation using self again on that. And I'm going to do observe thing.wait. And I'm going to say the observe thing's waits change. And on this one, I'm using the .debounce method. And so .debounce says, hey, take this async sequence and let it wait a bit. I'm specifically using a debounce of 10 seconds on this. It's a long time, but it's so you can make sure that we can clearly see that we're waiting for any other possible changes to happen. Because if, say, for example, a user is editing a text field or something inside a form on your project, you want to make sure that that doesn't get firing over and over again when you're trying to, say, for example, do a calculation event on something. And then we're going to merge those streams. And this is where the async algorithm comes into play that we're working with. That's where the import async algorithms comes in. And we use the merge method, and we take two different async sequences, and we combine them together. And now when either of those fire, boom, 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 that will then report that into a single asynchronous stream that we can then use inside our project. And that's what we access with the 408 change and merge stream. And so in this case, I'm printing the change.content, and then I will await my calculator event that I can just do. And it's really complex. And so we'll take a look at that really fast. And so let's go ahead and take a look at those pieces that we're working with on here. Before we get started, we've got basically it's just an adaptation of the default Swift project for when you're working with a Swift data object. You can see that I'm using a very similar approach with this. I've got my navigation link, and I've got my item edit view, which I've edited on that with a label of the text, the timestamp on that. So I just added that same thing with that. And so I'm using that as a for each on there. And I have my navigation link for my edit thing wait on this. And then we have over here, if I go to look at my backend section right here, I've got my calculator, really critical, calculation, but I know it's crazy. But notice it's been marked with the @model actor, so we can have it so it can be stored and have its own space within the concurrency environment we're working with on this. My control right now just has a reference to the DataObserver and the calculator. They're optional references because we can assign them after we init it, and that's just a nice little pattern for that. My custom schema is just to hold the information we're working with as a schema of the different data types we have of model data inside here. So it's a schema with item.self, datathing.self, and biggerthing.self as the types that are working with that. I know, critical stuff right there. And here we have our observation sendable. You can see it conforms to sendable as well. And it's just a quick little struct that has two string properties that are attached to it, the property name and its content. We just saw that in the init right there. We can have that going for there. Our models, we have the item.swift. I added a length to that in addition to the original timestamp and the associated init. We have data thing, which is a thing that has another weight and item as a component to it. And our bigger thing, which is in a relationship, has a delete rule cascade for all the items that are attached to it, as well as the update info, which is a string, and a var thing, which is a data thing, and those combined get initialized inside it as well. And then we have in our assets, we've got assets, and then we've got our app.swift. In our app.swift, we of course create our schema. You can see that get custom schema that we have right there to actually grab that schema we were just talking about. And then we have our state var, a big thing, a controller that get initialized in the app so they can be shared as environment variables throughout the entire app. Just what we do. We have our data thing view, and it's just a for each of all the things and their weights. And then we have our edit data thing, so we can change its current value with a text and text field and item edit view. Same basic approach right there. And our observation content thing we've been working with right here. So now we're going to go through and actually run through this project, see what we can do, and have this actually run for us so we can see the effect of those observations. I'm going to put the data observer back on screen so we can see what happens as we do this. And so we'll go ahead and run our project. So we started this off right here. And so I've got my change count on 0 because it's just initialized right there. And it's on that will set properties where that's going to happen. I made that small little change in my content. So I have the change count. And I have that fetch component count and the content change weight on that. And so it has a debounce effect because it's waiting. So that's why that 10 seconds happened for that before that actually fired. I'm going to go over here and add some items to this. And boom, those happen immediately. As I change them, you can see that that is automatically updating for that. And it's on the will set. So it's we have 4 items in here, but it still has the change count of 3 because the observation fires on the will set of said property. And then, so if I add another one, this is going to be 4. Boom, even though there are 5 items, so we can see that right there. If I edit my thing's weight, okay, so I change my current value. Current value is 1.11. That. My current value is 1.1. So if I change that weight, I'm going to go to 99.9999, and I'm going to go back. And now it's not going to happen. But if we wait just 10 seconds, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000, and watch that screen right here. Boom, we have the changed weight, 99.999 has been changed. That has, even though it happened immediately, it waited for that debounce effect we can see right here on that debounce for 10 seconds. So we can say, hey, I want to wait for this. Now this obviously 10 seconds is a long time, but I'm using it as a demonstration right here. So you can see, oh, we should wait for this. And so we can have that happen. And so as those things happen, that change event happens. Same thing with the deletion. If I go over here and I delete that item, boom, oh, boom. Those things automatically happen because there's not a debounce on that, so it happens immediately. So we can see when those things occur and we can use that. And so the import async algorithms, you can see it as a dependency on that. I have to add the dependency to my project. And so my Swift async algorithms has been added to that so I can have that working with it. But it allows us to have it so we can combine all those different things as long as they are the same type, which is why I created that observation sendable so I can collect different types of information and put it in a single thing. It allows us to observe many different things, use that merge function so we can combine as many things as we want. Now merge can take either 2 or 3 parameters for those asynchronous sequences. Hopefully in the near future they'll have variadic parameters so we can actually combine multiple things like that, so it makes it a lot nicer because if you have, say for example, a bunch of different types, you have to do a merge and then merge and merge and merge. That gets kind of messy, but hopefully we'll see a variadic sequence added to that. It's one of the proposals on the Swift forums to have that be added to the feature. But this is a great way you can do it to observe the asynchronous changes of at model or at observable data types. And so I can look to any of the changes that happen, say for example in this, anything that has a change inside that at model of final class item, that at model of final class data thing, any of those changes that happen to that, I can track them. And when those changes occur, I can then do code that happens because of that. And all I have to do is create an observer for that. The observer's requirement has to be that it conforms to uncheck sendable, and that I have I call it observe method, but you can name it whatever you want. But you have a method that you can call, and when that method calls, it's like, oh, here's how we're going to use this. We are going to go ahead and when those observe, we attach that, and we have a for weight the item. And if you don't care about the actual content, you just do a for weight underscore in, so you can just simply process that. You don't have to actually use something. I can even use it so I could send that change itself into the calculate method and have something else happen. And so that's how we can do some cool stuff with observations. I'll make sure the code for this project goes up on my GitHub repository so you can access it. The link will be inside the YouTube definition. But I hope this is helpful, and you can do some really cool stuff using Swift, using Xcode, and have some cool things so you can actually do some really cool analysis of the at model data types and at observable data inside your project. Cheers. See you next time. Have a great day. Bye-bye.